Hi, and welcome to another one of Dee's ADD videos. Today we're going to be looking at a few examples of completing the square. Basically, a recap from the concept video of quadratic functions. What we're going to be looking at is making sure that this a is 1. If a is 1, then what we do is we take half of this b number and we square it. And whatever we do, or whatever we get as an answer, we add to the c value. And we create what's called the perfect trinomial square that will end up factoring into this. It's a lot better if you just see it in action. And if a is not equal to 1, what we're going to do is we're going to factor out that a value, and it's going to alter one step at the end in which we multiply by a. Let's see it in action, okay? Here is some basic examples of completing the square. If I have something like this and a problem, the first thing I do is I look at the coefficient of the x squared, and it is a 1, so I'm good to go. So what I do is I take half of this b term and square it. So negative 4 divided by 2 equals negative 2. And then when I square that answer, I get a plus 4, right? So what I do is I write x squared minus 4x plus 4. And since there's no equal sign, to keep it balanced, what I have to do is subtract that 4 that I just added. Okay, so actually what I'll do is I'll write the new terms in a different color, that way you can actually see it. So we have a plus 4 minus 4. Plus 4 minus 4 is what? 0. So did we actually alter the problem at all? No, we did not. All we're doing is giving it another appearance. So what is the benefit of this? Well, this is a perfect trinomial square. If you watch the factoring video, this is one of the special case scenarios in which you can take it and write it in this form every time. What did I do there? Because this is a perfect trinomial square, I can square root the first term, square root the last term, and then just keep the sign, or it's whatever number you got when you took half of this b term, okay? And then negative 4 plus 5 gives me a plus 1, and it's now finished. All right, so again, half of b, square it, do the opposite since it's on the same side, and then factor it down. If you had a little problem seeing that, watch the special cases of factoring scenario video. Alright, so now here we have one with an equal sign. So again, the coefficient of x squared is 1, so what we can do is just take half of that 6, and that's 3. When we square that, we get 9. So here we're going to get x squared plus 6x plus 9. And then since we're dealing with the other side of the equal sign, it would be a minus sign. Plus 9, sorry. Got distracted by my puppies. One of the fundamental rules of algebra is if you do something one side of an equation, you do the exact same thing to the other side of the equation. So now this is a perfect trinomial square. Again, you know that because the square root of this times the square root of this times 2 is the middle term. Anytime you have a perfect trinomial square, you can rewrite it as x, half of the 6 is plus 3 squared. Okay? So that's the whole point of completing the square, is to create this perfect trinomial square so we can rewrite this trinomial into now a binomial expression. So here we have 9 plus 7 is 16. Now, I guess if we were solving for x in this problem, your next step would be to square root both sides. And if you square root both sides, don't forget the right hand side always gets a plus or a minus when you square root or do an even root. So here we're going to get x plus 3 equals plus or minus 4, and then subtract the 3 on both sides. So then if you did negative 3 plus 4, that's a 1, and negative 3 minus 4 is a negative 7. So you can use completing the square to also solve quadratic functions. All right. So here's another one. In this one, we're going to get a fraction. I know the F word for a lot of you guys. So 5 halves, when you take half of b, squared is 25 over 4. So we would write x squared, oops, don't need that line, sorry, plus 5x and then minus 7, and then since it's on the same side, we do the opposite. So this can be rewritten. There's no math involved, just whatever you took half of there will always be what it goes into here. And then here we would need to do a common denominator, so that would be a minus 28 over 4. And if you add those, that'd be, I guess, 53, it looks like. Okay. And if this was a y equals and we were trying to find the vertex by putting it in the standard form, well, the vertex by looking at this would be a negative 5 halves, comma, negative 53 over 4. And because this is positive, it would be pointing up. Okay. You could set it equal to 0 to find your x-intercepts. All right, so one last one we're going to do here. We're going to do an example where a is not 1. So remember, there's the added step of factoring out that common term. So 5, and then we're going to be left with x squared minus 2x. Now, even if the 8 was on the other side of the equal sign, I don't include it in my factoring out step. Just less messy that way. So half of negative 2 squared is going to be negative 1 squared is plus 1. But I didn't actually add a plus 1. I added 5 times plus 1 because this 5 says multiply everything inside. So 5 times plus 1 is 5. So if I do one thing to one side, I got to do the same exact thing to the other side. So then this can be rewritten as 5 like that. And then divide both sides if you're solving. And then I'm running out of space. I'm going to zoom in and maybe create a little bit more space. Not much, it looks like. If I square root and then add the 1, sorry, I ran out of space, I would get 1 plus or minus the square root of 13 over 5. Okay, that's if you're asked to solve using completing the square. All right, so here's some basic examples of completing the square. Don't be afraid of fractions. Just practice a few of these. They'll become pretty second nature if you do good 10, 15, 20, however many it takes for you to get the hang of it, okay? I hope I've cleared up the confusion. Practice, practice, practice. Thank you and have a nice day.